So we are going to solve quadratic equations, and we're going to begin by solving them using the method of factoring. So let's first remember our definition of a quadratic equation. And of course, our book says a quadratic equation is an equation containing a second-degree polynomial. In other words, we're going to have an x to the second power, and that's going to be our highest power. We may have something in front of our x squared. We may have something in front of our x. We may not have an x at all. And then we may have something out to the side. And we're going to first want things in standard form. We're going to want our x squared first, then our x, and then any number by itself out to the side with a 0 on the right in order to get standard form. Once we have that, we're going to use this zero product property, which says that if we have two things multiplied together and they're equal to 0, then either the first thing is 0 or the second thing is 0. Okay, so let's look at a couple of examples and see what we mean by the zero product property. And hopefully you remember how to do a lot of this stuff already. All right, so we have a quadratic equation here. Let's notice x to the second power is our highest exponent, but it's not in standard form. Not everything is on the left side. So the first thing we want to do is move the 8. And just recall that when we move something across the equal sign, it changes sign. So our 8 is going to become negative when it goes across the equal sign. And when we move it, we'll have 0 on the right. We now have it in standard form. So let's recall how to factor. We're going to factor the left side. So we'll make two sets of parentheses. And then we want the first two items in the parenthesis to multiply to be x squared. Well, that's x and x, certainly. Only choice there. All right, we want the second items in the parentheses to multiply to give us negative 8. Now, there are a couple of possibilities of things that could give us negative 8. We could have negative 1 and 8. We could have 1 and negative 8. We could have negative 2 and 4, or we could have 2 and negative 4. Let's notice, though, when the coefficient out front is a 1 in front of x squared, we can just think what factors of negative 8 will add to negative 2. Well, a negative 4 will, and a positive 2 will. And I have a lot of room in my parentheses, but all right. And of course, we could check ourselves by FOILing this back out, and it will give us x squared minus 2x minus 8. Now, if you've forgotten how to factor, get with me. We can go over this and do more examples of it. But now we're going to use that zero factor property, which allows us to set each of these factors to 0. All right, and solve these linear equations. So if we add 4 to both sides on this linear equation, add 4, this one's going to give us x equals 4. And over here, if we subtract 2 on both sides of this linear equation, subtract 2, whoops, this one is going to give us x equals negative 2. All right, and so our solutions are 4 and negative 2. And our right way of writing these is in set notation. Order doesn't matter, although we can certainly put the negative 2 first because it's smaller. But set notation is really just the list, and the list can go in any order that we want. All right, so let's look at this second example. Again, let's notice it's not in standard form, but it is quadratic since we have an x squared. But let's get everything over to the left side so that we have it in standard form. We have to remember that when the 7x moves over, it will be a negative 7x. And when the 12 moves over, it'll be a negative 12. And we'll have 0 on the right. Now, again, let's make our parentheses. This one's a little bit harder factoring. So we want to think, well, what gives us 10x squared? We could have 10x and 1x, but it's more likely to be things that are a little closer together. So let's do 2x and 5x. That's just the natural thing we think of when we think of 10 is 2 and 5. All right, now let's go over here to our negative 12, and let's think of factors of negative 12. We could have negative 3 and positive 4, so let's just try those. Now, one thing to note right here is we notice this doesn't have a greatest common factor. There's nothing that goes into all of these. So if we put the 4 here, it would give us a greatest common factor. So we don't want to do that. We can avoid putting it here because we know it doesn't have a greatest common factor. So we'll put the 4 over here. Now, let's check the inside and the outside. They have to add to negative 7x. And we may have gotten lucky, and we may have to move things around or try even like 2 and 6 or 1 and 12 to find out what's our proper choice. But I'm going to use my draw feature, and we will check the inside and the outside. If I multiply the inside, this is negative 15x. And I don't work well with a mouse, so let's see. Oh, that's not too bad. Having more trouble with my x, actually. All right, now if we check the outside, this gives me positive 8x. And when I add together negative 15x and 8x, that does indeed add to negative 7x. So I've got the right thing in my two parentheses. Okay, so now I'm going to go down here and set both of these to 0 and solve them. And I really forgot to put, let me get out of the draw feature. Forgot to put the equal 0 over here. Let's see if we can go beyond. There we go. All right, so we'll put 2x minus 3 equals 0, and 5x plus 4 equals 0. And let's solve these two linear equations. So I need to add 3 to both sides in the first one. And that's going to give me 2x equals 3. And then I want to divide my 2 out, which will give me 3 over 2 here. In my second one, let's subtract 4 from both sides. And we will get 5x equals negative 4. And then let's divide out our 5 on both sides. And we'll get negative 4 over 5. And again, we can put them in set notation if that's what our question asks for in my open math, or it might just say x equals, and you have to just fill in the box for the x equals. Just be careful that you don't put x equals twice if it says x equal already. All right, now our last one. Let's notice this one's not quadratic. The highest exponent is a 3. However, let's proceed in the same way that we did with a quadratic equation. Let's notice, first of all, everything is in descending order. We have the x to the third, the x squared, and the x. And it's in standard form in terms of being in that descending order. And there's a 0 on the right side. So let's factor this thing in the same way. However, let's notice immediately that we can take out a greatest common factor. We can take a 2 out of every single one of these numbers, and we can take an x out of every single term. So we're going to take out a 2x, and when we do so, we're left with an x squared. When I take the 2 out of the 10, I'll have 5 and 1 less x. And when I take the 2 out of the 12, I'll have 6, and the x will be out. Now let's notice that what's inside here can be factored further. And we can do it like our first one. Since the coefficient is 1 now, factors of 6 that add to 5 will be 2 and 3. So we'll have x plus 2 and x plus 3. Now we're going to set all 3 of those to 0. So we'll have that one, and that one, and that one. And then let's solve all 3 of these equations. If we divide by 2 to get x by itself, this first equation is just going to give us 0 over 2, which is still 0. And then the second equation, let's subtract 2 from both sides, and we will get x equals -2. And then this one over here, let's subtract 3 from both sides, and we will get x equals -3. And let's notice in this instance, we have 3 solutions. We have 0, -2, -3. Again, it's a list. I don't have to put them in order unless I want to. Notice that when we had a quadratic, we had 2 solutions. We had x squared, 2 solutions. Here we have x to the third, 3 solutions. If we had an x to the fourth, we'd have 4 solutions, and so on.